Chapter 3, Lesson 8, the last official lesson of Chapter 3, but I am going to take it a little farther tomorrow and do Lesson 3.9, imaginary Lesson 3.9. We're going to put that in air quotes, but that's what we're going to be doing. It's going to follow another way to solve a system of equations. So yesterday, the last lesson, 3.7, we did by graphing, all right? Graphing, I think that's kind of the long way to do it, especially if you're not a good grapher. You just don't enjoy it. Some of them don't lend themselves very well whenever they cross at a point that's way far off the graph. So this is another way to do it, and it says to solve it algebraically. So basically that's going to entail substitution. And when you substitute something in for something else, that's what happens. So if you look at this number 1 right here, it says y equals x minus 3 and y equals 2x. So basically, you're going to have something, if you know that either one of these, y is equal to this and y is equal to this, you can substitute one in for the other. Let's just do this. Y equals 2x. If it says y equals 2x, that means I should be able to put a 2x right there. So then I would have 2x equals x minus 3. So now you can solve it just like you have in the past. Subtract x from both sides. That crosses that out, leaving a negative 3 on this side. And 2x minus 1x is x. So now I know that the x coordinate of my point where they would cross, my x is negative 3. My x is negative 3. So now I can put that in to either one of these, either one of them. X is negative 3. So let's just put a negative 3 in. You could also put it right there. So if x is negative 3, then y is equal to 2 times x, which is negative 3. So that means y is equal to negative 6. Negative 6. And I didn't have to graph anything. That's it. Negative 3, negative 6. That is my solution. All right. Let's look a little further down here. I want you to go ahead and try A and B. Try A and B. Substitute one in for the other. If you look at A, probably the easiest thing to do, if y is equal to 2, you're going to put a 2 right here and solve. For B, y equals 3x. I would put a 3x right here and solve. So pause it, try it, and I'll be back with some answers. All right, so back with me. Your answers for A is the point negative 2. Come on. Negative 2, 2. And B, negative 3, negative 9. Negative 3, negative 9. Now, there is an easy way to check this. To know if negative 2, 2 is your answer, put in 2 for y, 2 for y, and negative 2 for x, and see if it works right here. Does 2 equal negative 2 plus 4? Yes. Right here, your y value is 2 equal to? Yes. It has to work in both of them for it to be true. But there honestly is no reason to miss these. If you substitute back in the x value and the y value into your system of equations, no reason to miss them whatsoever. All right. Moving on. We've got slope and standard forms. Slope-intercept we know from before. Y equals mx plus b. Standard form. Ax plus by equals c. So, number 2, solve the system of equations algebraically. So, this one's written in slope-intercept form. This one's written in standard form. Really doesn't matter to me either way. One of them has to be a slope-intercept, or at least one of them you have to have a variable by itself. We do. It says y equals this. So wherever y is, that's where I would put it. So if y equals 3x plus 8, then I would take 8x plus 4y. Now for y, we are going to substitute in this. 3x plus 8 equals 12. Now you're going to have to use the distributive property to solve that. So 8x I didn't do anything to, plus 12x plus 32 equals 12. So combining my like terms, I've got 8x and 12x, which is 20x. plus 32 equals 12. Subtract 32 from both sides. So 20x, that is gone, equals negative 20. Divide by 20. Whoops, 20. X is equal to negative 1. Now, if I know that x is negative 1, I can come right up here and put it right there. So y equals 3 times x, which we just found to be negative 1, plus 8. So 3 times negative 1, that is negative 3 plus 8, which is 5. So that means y is 5. So what is my coordinates? What are my answers? X is negative 1. Y is 5. Now again, I should be able to plug that in right here. Negative 3 plus 8, that would be 5. If I put in a negative 1, that's negative 8 plus 20, 4 times 5, does that equal 12? Yes. If it works for both, that is absolutely your answer. If it only works for one, then that means you missed it. It's possible for it to work in one and not the other. All right? So I want you to pause it. Try C and D, please. C and D. All right, back with me on C. If you worked these out, C, the answer is 2, 5. X is 2, Y is 5. Please write them as an ordered pair and not just X equals 2, Y equals 5. D, 2, 8. 2, 8. Okay. So with that, the only other thing we have is to try to make some examples out of word problems. So I know how you love word problems. So let's just try here on example 3. A total of 75 cookies and cakes were donated to the bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. So we need to get a system of equations out of this. So one sentence is going to be one equation. So a total of 75 cookies and cakes were donated. So I'm going to use, because they both start with C, I'm just going to use X and Y. So X, we're going to let X equal cookies and Y equal cakes. So we know that together X plus Y equals 75 because there was 75 altogether. That's one equation. Here's the other part. The other part says there were 4 times as many cookies donated as cakes. So here's what I would put. Does X equal Y? No. There were 4 times as many cookies as cakes. So which one of these is bigger? Which one of these is bigger? There were 4 times as many cookies. So that means this one is the bigger one. So how would I get these to be equal then? If this is 4 times as big as this, then I better times this by 4 so that way they are equal. So the amount of cookies equals 4 times the amount of cakes, if that makes sense to you. X is, cookies are, be grammatically correct, cookies are 4 times the amount of the cakes. These are your equations, all right? Now that X is by itself, I can take and substitute in 4Y right here. Maybe. Put in 4Y right there. So I would have 4Y plus Y equals 75. So 5Y equals 75. Divide by 5. Divide by 5. So Y is actually equal to 15. So if Y is equal to 15, put in a 15 for Y. If Y is equal to 15, what plus 15 is 75? 60. That means there has to be 60 cookies and 15 cakes. Now, again, check your answers. Check your answers. Do these two numbers add up to the 75 that it said were donated? Yes, it does. Are there 4 times as many cookies as cakes? Is 15 times 4 60? Yes, it is. Then you know your answer is correct. All right? So it's going to take you determining what is actually being asked in the question and then trying it. Okay? All right, so I want you to try under got it. I want you to pause it and try that. Okay, let's look at this. Under got it, E. One equation that you could write is y equals 2x. And y equals 2x is because he cooked twice as many hot dogs as hamburgers. Now again, you could have used D and H if that works for you. That's fine with me. And then the other one, you know that there were 45 altogether. So that means x plus y equals 45. Or again, if you use D and H, D plus H equals 45, that would work for me too. Okay, your answer. Solve the system algebraically. There are 15 hamburgers and 30 hot dogs. So 15, 30. Or you could write out 15 hamburgers, 30 hot dogs. Whatever you want to write. That's fine with me. Okay, so that's the end of the lesson. The best way to do these would be to try them, and I hope you paused and tried every single one of these as we went. And then that would greatly, greatly help you. So if you want to try some more on the guided practice, let me go down here and give you, since we got a little bit extra time, let me go down here and tell you what these answers are supposed to be, so that way you can try them, okay? Number one, the answer is -3, maybe. -3, 4. X is -3, y is 4. Again, I want you writing these as ordered pairs. Ordered pairs. So do not just say x is this, y is this. Okay, 2.5 and 7.5. Number 3, 1.8 and -7.2. So as you can see, it's perfectly normal to be getting decimals out of these, so that is fine. Just if you come up with a decimal, don't flip out and think that you did something wrong. How would you know if it's right or not? Plug it back in. Plug in 1.8 for this. Is -7.2 the same thing as 1.8 minus 9? Yes. That's what you got. Okay. And let's try one more. That's number 5 here. Sample answer. Y equals x plus 1. Because it says the number of adults was 1 more than the number of children. And the other one, it said that there were 7 people altogether. So that means y plus x equals 7. So what is my answer? 3, 4. There were 3 children and 4 adults that went to the movies. All right, so practice with those. See me tomorrow if you need assistance. Good luck.